So, I want to talk a bit about the ideas I have in my head for future architecture for the WorldForge, which are kind of, to some extent, driven by a desire to make the system robust and inspired by some of the changes going on in the architecture related to the meta server. The current architecture is very simple, as I described yesterday. We just have one single piece of server software, of which there can be many instances run by independent parties. We have one single meta server per organization, and as we're the only organization running this stuff at the moment, that means exactly one meta server in the world. All these servers register themselves with a meta server in a way that just simply verifies that they have an IP address. It doesn't really go any further than that, because it's a three-way handshake on UDP with a nominal secret. And then we have clients, which again are one single piece of software being run by a whole bunch of parties who query the meta server in a very simple, similar, unauthenticated, unverified 3-item way, and then build a TCP connection to the one server that they want to actually play a game on. So I'll first talk about the way I want to improve the Saga architecture to make it more robust and scalable. And I've lost my whiteboard marker in record time. So as I said yesterday, the server has got chunks of code inside it. It's got this COM chunk here, this server chunk here, and this rule sets chunk here. The COM chunk is the only part that can talk to the network, so all the network traffic is coming in and out here. Initially, when the client connects, all it can really talk to is the server part, which handles the accounts, the management login, all that kind of stuff. So there's a big path of communication here. And then once authentication has been fully set up, there's a path through here by which the COM's code can talk to the rule sets code and just generally interact with the world. So the first step, I think, is to draw a dotted line here and say this part of the server can be a completely separate binary from that part. Let's do that. So now we have the simulator, I'm going to call it. Shows my routes with other systems. And we have a inter-process communication path here, which may as well just be a network socket that removes the hard coupling between us being on the same machine. But this is a private link. This is not one that is addressable directly by any client, so it can be followed. And we have COM server code here. And the code is already reasonably well set up to deal with that. This means we now have a much smaller direct attack service, and we have, because this code here is mostly just dealing with the interaction between a client and a bunch of stuff that's specific to that client, or the way in which it interacts with other clients is fairly well defined in terms of operations and messages. We can actually have many of these in a shard. So we have multiple front ends all accepting. I'll call this a front end because it's the part that the user code directly connects to. This also shows my the terminology I draw from other experiences in the world. And then an eventual plan will be that rather than having a single simulator, we have the ability to parallelize and shard simulations so that we can run multiple simulators on the same world. And I don't really have a strong opinion yet on exactly how we can do that. There's a whole bunch of ways you can do distributed multi-shard simulation. You can divide it up by geographic area. You can have a more cunning hash-based simulation approach where you actually are able to handle transactions across multiple simulators, so you don't have to worry about geographical proximity. I'm not trying to make an statement about that at this point. I'm just going to say yeah, we can probably have multiple simulators. It's more difficult to have multiple simulators than it is to have multiple front ends, because the communication path between multiple front ends is much more abstract. If you want to talk to another account, there's pretty much no limits on why you shouldn't be able to talk to another account. You just pass a message over to the front end they're logged into, they pass messages back to you, that's no problem. So, given that we want to be in a situation where we have multiple front ends, multiple front ends and multiple simulators, that is probably the most straightforward way in which we can split stuff up. We also need to then start thinking about ways in which we can have multiple machines working together in a cluster. With any luck, with the simplest possible configuration. But because I've been working far too long in various different online industries, the idea of having hard configured special purpose machines kind of appalls me a bit. And the idea of you hard configure the host name of your central server. So I've been starting to think about ways in which we can run a cluster of machines that are going to be running a whole bunch of these front ends and simulators and stuff in such a way as we don't have to do that. So, an idea I've been playing with is, say you have a situation where you have a bunch of machines, these are physical machines. But for the purposes of development, they could be virtual, there's no actual value to that. So we call these physical machines.
Independent operating systems of some sort. Independent operating systems of some sort.
Yeah, independent system images. I think it's a good time. And each one fires out a master daemon that's going to be in charge of that. I've been mentally toying with the idea of calling these things signets, which is spelled like this. This is a derivation from the name Cyphersys, because it's part of the Cyphersys architecture. It's got the word net in there to know that it's looking after the sort of network arrangement of a cluster, and it's like a pun on the thing for a baby swan. Right? And these things can discover each other on the local network using some kind of multicast or local broadcast feature, and they work out how many of them there are. And in the initial configuration, they go, hey, here we are working together, we've got some sort of nominal symbolic identification that we all believe that we're part of the same nominal shard, but nobody's in charge. So they have an election. They decide, they work out together who's going to be in charge first. And one of the algorithms that you can use for this, which I have read about some, but I don't have a good understanding of it, it's called the Paxos algorithm, which is a way of achieving consensus between unreliably connected distributed parties. When the actual result of the election doesn't really matter, it's just you have to have a result. So these guys have a Paxos election, and one of them becomes the master and is promoted to being a swan. Another pun that I thought would work quite well. Does that make reasonable sense?
I think so. You're using basically the same idea that a multi-node cluster would use to determine
A multi-what cluster?
a multi-node cluster.
Yeah.
Use.
I mean, this kind of master election kind of stuff is very familiar to for anybody who's worked in cloud computing.
I'm just trying to figure out if so, I mean, what they're doing sounds pretty similar to the way Windows did network browsing years back, and that had various issues. And I'm just trying to remember
What the various issues were.
What the various issues were,
these things are imperfect.
just trying to figure out if we are running into any of them. I don't think so. I think the biggest issue was that the Windows networks use broadcasting a lot, and they had this funny idea of broadcasting in repetitively, because some machines might not be like doing the right thing, so you just kept broadcasting and all of that mess. And I mean, if we're not doing that, we should probably be fine. I don't think there were any like more deep down issues with that. But let me think about this a bit, because this sounds amazingly familiar to what Windows network browsing was doing, and Windows network browsing is pretty crappy. So from Potter's
Yeah, I'm familiar with a lot of systems that use this kind of mechanism that work absolutely perfectly reliably. It's not an impossible engineering problem or anything that can be done well.
I think the problems were elsewhere.
So all these system images now have one single authority that's in charge and a whole bunch of other stuff. There's no need for this to be done every time you fire up a cluster. This is what we do the first time, and this basically means that an inexperienced engineer can be creating a shard like this without having to worry about handwriting a whole bunch of concrete file. Once we've done this, the node that becomes the master begins to use a different process to identify themselves as the master. And there are a whole bunch of algorithms, which I won't go into in any great detail now, where you can use once you have a configured system in which a whole bunch of components can be the master, but only one needs to be at any one time, but the mastership needs to fail over to another system. So the master will start having a view of what the configuration. Let's in bold on this one, because I say this one has won the election and it's now in charge. And it uses a set of heuristics to go, hey, well, I now know I'm a member of an N-node system image cluster. A typical sane starter configuration for this is that we fire up a couple of front ends on each of them. And then we fire up one simulator per let's say one simulator per processor core on each of them as well. This is just around guess exactly what the same ratio of resources to processors will be heuristics that you develop on the line based on experience. And what it can then also do is sort out a way for us to do the incoming front-end stuff. So this master is now responsible for registering with the meta server. So let's talk about what the meta server will do in this new world order. Let's move these three down here into a box. This is a shard. This represents that, right? I'm going to clean it away. I need to give this one a name because, in my view of the way the world works, each shard, which is from in the common gamer parlance, a game server, you know it's multiple servers at this point, has a single unique DNS compatible name. And well, let's say this one calls itself Agrilan after the big village in the first Open game. This is called Agrilan. I can't write RS without I dot
Just from looking at the camera, you probably don't want to go much further right for this.
I'm here on the right bottom, okay?
Yeah, that's pretty much the limit.
Okay.
But you have plenty of space to the left.
Okay. So, actually I'm going to stand this side. And we have a meta server up here running on a unique location which we can discover. And this is let's call it the WorldForge.org meta server. The Swan, Site 1 thing, here, because it's in charge, is responsible for registering. So it goes, hey, I'm new, I want to be Agrilan. We have an extended protocol now that actually embeds this short, and it's locus only DNS compatible ASCII. This also has like a long name which it can use to present to players, but when it's sort of the meta server, so now to use a short name. And the meta server goes, yeah, sure, nobody has ever been called Agrilan before. And then it does some kind of crypto discussion, which allows this server to permanently claim the name Agrilan identify it by itself later. I have done absolutely no design on the scripted stuff yet, but I would want to do some kind of key generation, key exchange at this point, so that this server from now on can always be Agrilan. Next time somebody tries to be Agrilan, the server will go, that's taken. You have to prove to me you're the person who was Agrilan before. This is a bootstrapping a new configuration. And once this is successfully done, this server now permanently reserves Agrilan in its namespace for this. And this namespace, in the sort of naive initial bootstrap of the design, will be agrilan.shards.worldforge.org in real DNS. So shards.worldforge.org is delegated to a DNS front-end running on the meta server using PowerDNS in our current plans, and sending a query saying you want agrilan.shards.worldforge.org. This will respond with an A record pointing you at here. That makes sense? Trying to pull ideas together in my head.
Why DNS and why not an internal database that meta manages?
Sorry?
Why DNS and not an internal database that meta server manages?
Well, it is an internal database that the meta server manages, and that's the only place that association lives. PowerDNS is not being used in this case as a conventionally configured authoritative name server. It's a front end that talks to the DNS protocol that has a tight coupling to the meta server. So when you do a query for agrilan.shards.worldforge.org, it goes to the usual DNS search path in the world, the delegation runs to here, and the PowerDNS front end sends a message to the meta server saying, hey, I've got this query, but give me a response for it. And the meta server builds that response to that query out of its internal database with a suitably short TTL based on the specs of the meta server protocol's ability to guarantee how long that A record is valid. You see what I mean? Because there's a timeout with this registration involved in repeatedly verifying the handshake, and we don't want a TTL on this that is longer than our guarantee. We want the IP of this to be possible to change and for it to update in a reasonable amount of time. Does that make sense?
Yeah, but I'm just trying to reconcile this with the way that Ryzom does this. Shard Unifier, which would be their meta server login service, the welcome server says, I have front ends available on these addresses.
Yeah.
Because it'd be on multiple IP addresses.
So this is very naive and beginning at this point. There are plenty of ways in DNS we can go to a better, more addresses, more that kind of thing.
Well, all we do is we dump it into a MySQL database. This shard ID is this IP address, and that's how you get passed down.
Yeah, but I mean, pretty much.
It doesn't have to be the system.
I mean, this is pretty much doing the same thing.
Yeah.
But
But you're just using the DNS protocol for it. To tell the client.
So I'm making the assumption that it's trivial to install MySQL. It's not necessarily as trivial for someone to do all the DNS, administrative DNS.
There's no administration required.
Okay. This DNS thing just runs for the meta server.
Right. So
basically, the only thing that you actually are punished with is that you can't run a generic DNS server on the same system that runs the meta server.
Yeah, the meta server occupies port 53 with its PowerDNS front end.
So this works well, assuming that you guys are the only ones that run a meta server. Then I don't really have to care. Is that an assumption?
Well,
being a new organization that wants to run your own meta server infrastructure, there will be a whole bunch of extra engineering to be done. But I don't think it'll be. You don't have to do any of it at all. It will just register with our meta server. You will get the unique name or names that you want for your shards, assuming that it has already taken them, and your stuff will be in DNS then.
Right.
Now this is the naive, easy way to do it, because this is a single IP address in this case. When we want to deal with multiple front-end things and we want to be a bit more dynamic about the ports, because the well-known port situation we're doing at the moment is not a great one to be dealing with in the rest of the world. But we can start talking about using service records rather than A records. So you'll be searching for underscore WorldForge underscore TCP agrilan.shards.worldforge.org. And it will come back with a bunch of server records. You're familiar with SRV records? For the benefit of people who might be watching the video, an SRV record specifies multiple addresses and IP addresses and port numbers that are available running the service. So you can, in this world where we've got multiple front ends running on potentially multiple addresses, we'll obviously have to have a way of ensuring that we can check whether the IP addresses are correct and trustworthy, but yeah, we can just publish that information easily, again, using DNS. Now, the reason we're using DNS here isn't for the conventional client fires up, wants to find a server, just asks for one. But once a client has done that, it can populate its local user my favorite servers list with the short names, with the verbose long name, which might be my Angulam server. That's a purely an issue with discussion between the client and the server whether or not they have that name. But that server does not need to go straight back. Have I written that off the side?
Sorry, yeah, you're certainly go off the side.
It doesn't matter. There's a long presentation name there, which the user will want to see, and the server administrator will want the user to see when they're dealing with that server. When you fire up a client that's already been used to play games, there's no need to go to the meta server again to find a list of new servers when you're pretty sure that player is going to be wanting to play on one of the servers that's already played them before, so that has a locally cached thing, and when it wants to go there, it can go directly to here. So we'll be talking to the meta server over DNS, but in a nice, clean, scalable way. It is way more scalable to talk to any centralized infrastructure over DNS, because DNS has always been designed to be brilliant and scalable this way, right? Do we agree on that, right?
And I mean, you basically could just add generic DNS caches if the load in the meta server rises. So I mean, you could like add more DNS front ends.
Oh yeah, we can. Yeah,
charge to the WorldForge store using existing architecture, so you don't have to scale meta server. You just like pop in more DNS proxies.
Yeah, this hopefully should just really reduce the amount that as the client population grows, they need to hit the meta server. So the client will still hit the meta server for great big lists of client information, given a search link, but it won't have to hit it when we're actually looking for a specific server again. It's not okay to cache IP address stuff in the client, because in dynamic hobbyist world, these IP addresses move around. Okay. So I have slightly more vague ideas, which involve then saying that maybe in a separate delegation or a subdomain under this delegation, this also has the DNS authority for this. So, for example, has it for internal at WorldForge.org.
You're leaving the screen again.
I'm probably going to out of space in the other direction now.
Yeah. So you're clearly fine there.
I'm clearly fine, right. And under internal at WorldForge.org, we have the subdomain Angulam. And that domain is delegated to the DNS front end running here. So if anything in this shard wants to go, hey, I want to speak to a simulator so we could do an SCV record for underscore sim dot underscore TCP diagram.internal.worldforge.org. The DNS goes to search, hits here, this says delegate to here. This would not necessarily be talking on a port that was accessible outside, but it could be if you wanted it to be. And whatever the querying party here is doing is able to talk to here and find out what SRV record is telling it, where all these emulators running inside this particular shard is. And again, hopefully we now have a way, a clearer, what's the word I'm looking for? A scalable, robust, existing protocol way of talking about all our name service requirements inside a shard without having to worry about writing new protocols, worrying about how to make them scale, all that kind of stuff. Does that make sense? Or does it sound like I'm completely insane? I don't know whether it makes any sense to do it as another delegation under this domain and make this more complicated, or do it as a separate delegation. It can be discussed. What shall I talk about next?
Do you have any ideas how you're going to end up splitting the front end from the simulator?
The two parts are not that tightly coupled at the moment. I'm going to have to do some refactoring inside the server code for a few little places where the path of operations as they flow around the server part and back into the wall sets isn't perfectly suited to this and a little bit inconsistent. There's a few special cases in it, whereas if I can refactor it so where everything works the same way, that will help. But that isn't the way the code is nicely modularized and partitioned already, so it shouldn't be that much work. The main effort is going to be making sure that the front end, multiple front ends can talk to each other cleanly. That again also shouldn't be that difficult because of the way communication within the front end works. There's no spatial simulation, for example. Sharding the simulator is going to be much more difficult, as I'm sure you're aware of being somebody who's worked on a game project. But actually I'm not that worried about that in the short term because sharding the front end solves a whole bunch of scalability problems and also makes the whole system much more robust against attack, that kind of thing. A next situation of being able to shard the front end is that you can have two different types of front end. You have the listening front end, which has the listen sockets on it, which accept incoming stuff. And in a world where you have SSL, which I believe it is necessary for us to have SSL or TLS, in order to make sure our client streams are reasonably secure, this is also the only part of the system that needs to have certificates and needs to be able to negotiate the keys that are necessary for SSL communication. And running parallel to that, connected by a Unix socket, you have the runtime front end. And when this system here has finished listening to a connection, negotiating the protocol variant, we're going to talk over it, set up the SSL, and then install that kind of stuff, we can pass the file descriptor across a Unix socket to the other process, hand off necessary SSL stuff to make sure that it can keep talking, and this front end is then able to continue the communication with the client. The client doesn't see anything happen. It is literally, if it's on the same machine, you can literally pass the file descriptor through the socket to the other process. So you have them talking to a different zone. This means this is the only part of the system that needs to worry about a whole bunch of the range of DOS attack scenarios that you might end up under. Because if we ever get any size whatsoever, we're going to get a situation where somebody hates us enough to DOS us. That always happens.
Or likes us enough to DOS us, I mean.
Likes us enough to DOS us. And it may well be that it's not us that it's like. It might be another player in the game. And having had a bad interaction with another player in the game, they want to DOS the player's game to the point where that game is ruined. This can be tightly coupled, have no direct connection to the rest of the game infrastructure other than this single unit socket. And then all the clients talking to this code, which actually has a whole bunch of logic in it, involving accounts and all that kind of stuff. It's impossible to establish a connection to that without jumping through all the necessary hoops involved in setting up a healthy connection. This is a situation, as a scheme I have used a number of times in my professional life. I've been exposed to systems to use it, and it works really well. What else? The SSL stuff is something we need to do. Not with any particular urgency, but I really feel it's an important part of that requirement. linked to that, I think it will be really interesting to see if we can run some kind of CA on a meta server, so that when I'll explain.
When they register,
They actually get a certificate for agram.worldforge.org with a star array record.
So
Record on it.
can PowerDNS do DNSSEC?
I know very little about DNSSEC. It's kind of crossed my mind, and I've gone, I wonder if it can. I don't know enough about DNSSEC to even know whether it's useful to us.
I can have a look. I mean, I'm not sure if it's going to help, or if just like making sure that we use the DNS signing that is different from DNSSEC. I mean, there's like DNSSEC tries to verify the complete chain of things, and we might be able. So for this internal scheme, for example, where there's more names that can be registered and things like that, it might make sense to actually require some sort of signing because we're agreeing on the key anyway.
Yeah.
But I might have a look at the DNSSEC stuff again. I haven't dealt with that yet.
I'd be interested in what you think about it. I haven't really ever had a chance to deal with it too much. But I said that's a completely different issue. But I've mostly been thinking about the possibility of us having proper decent SSL certs being generated by our NCA. And that gives that cached client list that the client will have, the cache server list that the client will have, a little bit more robustness. At the moment, our Ember does store credentials for repeated connection in plain text in a way that would leak your credentials to any aggressive third party imitating your server. So it just gives away your plain text password. So we have a hell of a lot of work to do on authentication. But there are huge numbers of technologies we can use to make authentication work way, way better. Like using proper. There are a whole bunch of, I can't remember the names of them now, but there are a whole bunch of things that HTTP has done over years which don't involve you having to send your plain text credentials ever, even on a encrypted session. I probably have exhausted my creativity at this point. Any more questions?
Alright, so you're going to split simulation out into a separate process.
Yeah.
Should I see, is there any reason you wouldn't use TCP instead? So that they could be on a distinct, different physical box.
The link between the runtime front end, that's differentiated from the listening front end in this scenario, but I'm not going to do this listening runtime thing yet. The connection between the front end and the simulator would be TCP.
Okay.
Yeah. This one has to be in socket because you can't handle file descriptors off. It's impossible. It's a different terminating end. Can't really go into too much detail about the Atlas stuff because I haven't built up that kind of stuff today, so it's difficult to discuss in any depth there. So I'm going to call this a wrap for now. Okay, thank you very much for listening.